Alright, what I want to do today is just show you the spectrovis and also introduce you a little bit to the LabQuest 3 software, or the LabQuest 3 operating box, the black box here. But we have our samples that we prepared, we diluted. I actually have the blank, and then I have 1 through 9. So 1 is the most concentrated, it's actually the mother solution, and then we're going to drop in concentration to that least diluted solution. And remember, what we're going to try and do is run in percent transmittance mode. You can see the spectrophotometer has been connected to the USB port on the LabQuest data box. So that's how that's connected. And when we run this experiment with UV-Vis, it's best to have the data box plugged in the entire time. Sometimes if it's running off the battery of the LabQuest, it kind of makes this UV-Vis light flicker, so that could cause trouble. So now we're going to just kind of start working on the details here. So one of the ways to start getting the instrument ready is I'm going to actually just drop this blank in there, which is just pure water, and you can see an arrow on the cuvette, and you usually want to line it up with the arrow on the spectrophotometer. But to make some sense of what's going on is there's a divot in the cuvette that's sunk in. That just saves volume. So instead of being a full centimeter wide, it's about a ½ centimeter wide, so it's kind of cut in here. But then the optical glass, the business end, the glass the light passes through is the wide 1 centimeter flat sides. But there's a little arrow on there to remind you which is which. And then on the spectrophotometer, you can look in and see the light, and it makes sense that the light is generated on this side and heading to the detector that way. And there's actually an arrow on here, so I can put arrow on arrow, and I'm going to put the blank water in there for right now. Now let's go over it. So now we're at the LabQuest 3, and there's an on and off button here. I'm going to turn this off for a second so you can get it just like you would have got it when you showed up. It's off, so I'm going to turn it on with the button. Top left corner. See a little bit of a home screen there. Cancel. It was trying to auto recover. My odds shut down. So you might show up here in the sensor file, or you might want to sometimes show up in the home screen. There's a little home up there. This has some other options. There's a calculator on here, experiment viewer, just different things. We're learning this software ourselves, so together we might learn some of these apps, but for right now we're going to work in the LabQuest app. You push that, so it knows that there's a sensor on there because it's saying, according to the USB hookup, I think I'm reading absorbance. So it's ready to read spectrophotometer. We're actually wanting to read in transmittance today. So that's one of the first things I'm going to do is I'm going to change the spectrometer mode. So I hit the red box, drop down to spectrometer mode, and I'm going to say percent transmittance because that's what today's experiment is. Later on, when you do the kinetics experiment, you'll run in absorbance mode. So it's good that you're familiar with how to do both. So right now I'm in transmittance mode, and the mode over here says full spectrum. I'm going to pull that down just so you can see what that means. It means I'm going to literally look from 400 to 725 nanometers, sample times 15 microseconds, wavelength smoothing, samples to average, wavelength range. We're just going to assume that the sampling time, how long it opens up and takes a shot, is optimized on its own. That's kind of like a shutter speed, like exposure time. So if I open it up for 15 milliseconds, if I open it up for longer, it might pick up more light. Wavelength smoothing is a way to get rid of noise. With these instruments, it doesn't seem to work very good, but samples to average quite often can be helpful. I might move that up to 5. That means I'm going to take at least 5 15 microsecond scans and then average those together and say that's what I'm going to get my data off of. This is too small of a range though. 400 to 725 we need to expand that out to the end of the visible. So about 400 to 900 is good. Technically it's 400 to 1100. I'm not sure how far these spectrophotometers will see, but this is okay. So we're running a full spectrum scan. All right, so everything's in good shape. We're now going to go where we're looking. There's it looks like a little graph, and that's what I'd like to see this as. So this is it comes out as a graph. It kind of shows you the low energy in, the high wavelength in 725, the red all the way up through the violet. So yeah, we can see the entire visible scan here. Now I'm going to change a couple things because I know I need to see all the way up to like about 900. And the other thing is this color is neat, but it's a little distracting. So let's kind of set up some things in the graph options. The right, let's set that up to where we're going up to the 900 we have set up. And then anything else, I think we're good. Okay, I think you can also tell the auto scale. That can be helpful, I'm not sure. So now I'm hopefully looking over the whole scan. I'm going to take that color off. Show graph. So what I do is pull down graph, show spectrum. I turn that off. That gets rid of that color. That's kind of nice. All right, so we're ready. We're going to want this thing to calibrate, but if you just push, play here, it knows it needs to calibrate. So if I push play, it says I'm taking the dark sample. So what that means is it's going to basically turn off the light, read, and if it reads anything, it knows it's coming from the outside, and that it should eliminate that from the spectrum. Now it also has a built-in warm-up feature because a lamp, anytime you do electronics, you should make sure they warm up. LEDs warm up considerably quicker than the incandescent lights. So remember the old light bulbs that put off heat? We sometimes use theirs. They're a little more precise, but they have like 30-minute warm-up times. These are done in, as you saw, about a little under a minute and a half. So we'll just hang on to that and let it warm up. You don't want to skip the warm-up because we want to make sure the LED lamp's on. That'll help a little bit with the precision and accuracy. So it doesn't matter that the blank is in there because it basically kind of turns off the light. It isolates the light for a minute and reads. And anytime that turns off, you can just kind of click on the screen and it'll come back on. So we got the dark spectrum. So on your lab 1, page 10, you have a place where it says dark spectrum. You can just check that box saying, hey, check. We did a dark spectrum correction for this instrument. Lab 1, page 10, check. I'm about to check the dark spectrum box. All right, cool. I'll just flip over there for a second so you can see it. All right, I'm going to check that thing off. All right, cool. Now, place a blank cuvette in the device, which we've already done. We're going to tell it to finish the calibration. So now what it's going to do is it's going to look at that, and that blank cuvette is actually water. So I'm going to finish the calibration. Calibration is complete, and I say okay. So now this could be informative. It's actually, when we're done, it actually starts reading right away, and you can look on here and see that basically the line about 100% transmittance is where the line sits. If I want to, I can just push the stop button and it'll grab that spectrum and kind of blow it up so we can see it. Sorry, my button here, we'll do this. Come from this side, get that button, turn it off. There we go. And sometimes it's good to auto scale once. So I pull down graph auto scale once, and that just kind of looks at it. So we're looking at this. It's got a little bit of noise, but basically remember that this is all between 99.8 and 100.4. So that's pretty darn good. You're basically very little travel away from about 100. So that's good. Now, we're actually at this point ready to start reading our copper spectra. We just need to know what wavelength should we read at, right? So I'm going to start at reading again. It says, are you going to overwrite? It's like, yeah, we can. We can discard this because this data we're going to write off the instrument ourselves. We'll write down what we read on the instrument onto our notebook or onto our notes. So here we go. I'm going to jump back over here to the other screen. I'm going to set up a little sample table. Basically say, okay, I'm going to do sample 1. I'm looking on lab 1, page 10. I got sample 1 through 9, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just reminding myself that number 1 is the mother solution. And then I'm just going to record the percent transmittance. Pretty straightforward. I could put that right into my, it's column 2 of my lab book. Right? So here we go. I'm going to take and switch out sample the blank for the mother solution. That's sample 1. Put that in there. See what we're seeing on the readout. I'm going to, I want to auto scale once. There we go. All right. So I got a little bit of a problem because somewhere around 0, right? This is the 0 line in here. I'm getting this thing. I'm not getting enough light through it to see anything. I can see this is probably where the peak shows up. See how it's starting here? It doesn't absorb anything, and then when it gets down here, it starts to absorb. Sure that my screen is your screen. Okay, yeah. So as we get along here, you can see that it's not really it's not absorbing any transmittance. It's like down 0% transmittance. So that is too concentrated of a solution for this instrument to run. We anticipated that, so the next sample should come on scale. So I'm going to change to sample number 2. All right, that's better. Now we're getting a reading. And so now what I would like to do is identify what that wavelength is, right? And I can go ahead and record my result, and then I can start running all the other samples. In fact, with this instrument, it's better, once we determine this wavelength, to kind of run in a little different mode where we just read at only that wavelength. But first we've got to figure out what that wavelength is, where that percent transmittance is, where the most absorption occurs, right? The least amount of light gets through, the most absorption occurs. Okay, so here we go. How can we figure out where that is? We stop reading. We now go to analyze. We say statistics. We're reading the statistics on the percent transmittance. It says the minimum is at 30.7, so that's actually one of our data points at 736.16. So I'm going to go over to my notebook, and in my case it's my piece of paper, but that is sample number 2, the percent transmittance, 30.7. And I'm going to make a note. What wavelength is that? 736.16. So that is the wavelength of interest that I'm going to run the rest of the experiment at. All right, so now I'm ready. I can switch back to sample number 3. Not back, but continue on. Arrow on arrow. Sample number 3. So we're going to change from this full spectrum. We're going to pull down We're going to do events with entry. We're going to do selected events. We're going to change this to units to nanometers. It says average over 10 seconds, but we're not going to do that. We're going to say OK. And basically at this point, we are ready to start running. So I'm going to push go. I'm going to go back to that speedometer. So this slows down a little bit. Earlier it was reading pretty quickly, but remember that we have this set up to just give me an average every 5 seconds. So this gives me pretty good reading. It's around 39.23, but it's bouncing a little bit in that 10th place, so that's okay. So I'm now going to sample 3, and I'm going to change that up to 39.3. Now I'm ready to start clipping. All right. I'm going to change from sample 3 to sample 4. Now I'm reading at 44.1, 43.9. Let's see here. There we go. Let you see the screen there for a minute. 44.0. That's holding, so I'm going to put 44.0. 4.0, going to switch out. Again, arrow on arrow. I'm now to sample 5. Switch back. Jump it about. Sample 5, get that in there. Make sure it's arrow on arrow. Okay. Okay. Oops. 54.8. Sample 6. Okay, now let's go over to Excel. So what you could have prepped beforehand, maybe even before you come into class, hint, hint. You could be working on table, on lab 1 page 10, you could go ahead and set up your copper concentration on Excel. Highly recommend this. So remember, this could be plus, and Excel is interesting. If you have the newer version, you can highlight that 2+, pull down the font, and actually do a superscript. So that's unique. Older versions of Excel don't always do that. And so you're actually working on the percent transmittance. And then the other piece you could go ahead and work on, just to check your work, is do the negative log of T. Now, if I put that in here and I start off with a negative, it's going to think it's mathematical formula. So I'm going to start off with like a quote or a apostrophe, and then I'm going to just say negative log of T, and that's just a reminder what's in there. So remember, we started off with copper at about 1 molar. And now I'm gonna do something different here. This is gonna be a little bit different, but when you graph, you usually graph from low to high. So I'm gonna actually do this sample backwards, because I know that the least concentrated solution is 9. So it makes sense when you get your graph, because usually as you move left to right on the graph, it goes high to low. There's ways to do this in the Excel graph itself. I'm just going to flip the table around. So what number 1 is concentration of 1. Number 2, and you know, you can put more digits on that. 1.000, cool. Might disappear. And this one is 6 e to the minus 3. Excel knows that scientific notation. 5e, whoops, 5e minus 3, 4e. Notice that if I just use a lowercase e, it still knows it's in scientific notation. It's kind of neat. Now, here's a nice little trick about Excel. If you give it a few hints, and then you get to the edge of the box, and then you drag it up, it'll follow the trend, fill in for you. It knows what you're trying to do. Then this last 2 samples were 5e to the minus 3. I made a mistake already. 1 e to the minus 3. And if you guys are at home watching this, you're thinking I'm crazy. Yes, I missed it. That's 6 e to the minus 2. There we go. 5e to the minus. Take a 0 out. Take a 0 out. Now, let's try that again. Running from my trend. Click and drag up. There it is. Now, let's see if this makes sense. So we got it reverse order. Sample 1 is 1. It's nice if you want to. You can highlight this. Call it scientific if you want. You can then give it digits. See, we want to get the significant figures in there, and that is all correct. This one actually though should be it can have one more digit to it because it's more precise than the others. Good. Now we're in business. And we're off to the races. So now let's enter in the data. Here's what we know. This one's not applicable. Inner numbers. Number 2 is 30.7. Oh, come here. Here we go. Where are we, people? There we go. Let's try these again. Turn my num lock on. Okay, 30.7. 393. 44.0. 54.8. 65.6. 85.3, 92.3, and I'm a little reluctant to use that last point because it was beyond the instrument. So I'll tell you what I'm gonna do. I'm gonna also call that NA, because if the blank reads 100% and then the sample reads 100%, I don't think that's proper data to use. So here's what I'm going to do. Now, the reason I'm doing this is to make sure my samples were correct. So we know that they'll give a straight line if I do the negative log of this. So I'm going to now apply whatever I've got going here. I'm going to say I want you to go over here, take the negative log, yeah, we're talking about log base 10 of that cell, enter. Because of the NA, nothing's there, and that's okay. That's what I'm after. Ah, close. Got a little bit of a clue because I saw those negative signs. I was like, what's going on? But I forgot one piece. C10 is percent, so 92.3%, but I actually need to turn it to a decimal equivalent. So I'm going to divide it by 100. That should work. Clear all this out. So look at the formula again. Take the negative log base 10 of whatever I have in cell formula, position C13, divide that first though by 100, and away we go. That is correct. Now I can copy that down. I get my cursor, I drag it to the right hand side, it turns to a black cross. No, earlier it's arrows or a white cross, but when it turns to a black solid cross, I can drag and drop and it's going to copy down. And so now I actually can see if this set of data, and I'm just doing a quick check, so I might, I'm going to delete this out of here. There we go, because I want to graph this really quick and see if it gives me a good linear fit. Insert. We're going to do a scatter graph. Okay. Look at that guy here. I'll get it, maybe get it a little smaller so you guys can see it. There we go. Now, I'm going to right-click this, and I'm going to select my data, and I only want the negative log of t, right? So I say that. Ooh, that might be a nice straight line, so that might be good data. I can right-click it. I can add trend line. That's what one of these options is down here. Add trend line, linear. I want to put an equation. I want to put in R squared. Let's see what we got. All right, that's a 0.9938. That is good data. I'm good to go. So with that data, I'm ready to proceed on with the lab.